Hello, Matt Davis here with more homework quiz help. This one comes from section 8.3. Suppose a random sample of size 46 produced a mean of 1907.42 with a standard deviation of 204.57. Determine a 95% confidence interval for the population mean. Enter only the margin of error E of the interval below and round your answer to 2 decimal places. So first of all, we're going to make a couple changes in the interest of giving help rather than answers. So we're going to switch our confidence level to 90%. And then our sample size, we're going to switch up to 51. And while I'm calling that sample size, I might as well label that with N. All right, so now let's think about where we are and what we need to do. They want us to determine a confidence interval. So we're doing a confidence interval problem. And they want it to be for the population mean. So we're in mean land doing a confidence interval formula. So we should start out by writing down the formula for that, which from the formula sheet is x bar plus or minus t star times s over the square root of n. So that's the formula we want to need. That's the formula we want to use. So we need to start gathering the pieces for that. They said that we have a sample that produced a mean of 1907. So that is a sample mean, and therefore is x bar. And then again, we have a sample, and it's producing a standard deviation of 204.57. So that 204.57 is our sample standard deviation, or S. So we've got N, X bar, and S. The only piece of our formula that's missing is T star. So we'll work on that. So let's set up a bell-shaped curve. 90% confidence is what we're doing, so we'll put 90% in the middle in decimal form. That would be 0.90. And then that leaves 0.10 left over, and we split that among the two sides. So cut that remaining 10% in half, and we get 5% for each side. And this right boundary over here would be our T star. Just a reminder, always add these three up, make sure you get a total of 1. Very common for people to have a mistake, and if they added these together and checked to see if it was a 1, they would have caught that mistake. Common mistakes are forgetting to split the leftover area into the two sides or to put the decimal in the wrong place. Either of those will throw off your t-score. All right, moving on with the t-score. That t star that we want is going to be the t with area 0.05 to its right. So that's what we're going to look for on our table. But before we can go to the table, we need a DF, and that comes from our sample size. We have an N of 51 on this problem, and the DF is N minus 1, so that's going to be 50. So when we go to fill in this t-score right here, we need to make sure we're using a DF of 50, not the sample size of 51. So let's go have a look at the table and get to work on that part of the process. So here's our t-table. Zoom in a little bit for you. So we want t of 0.05, so that's going to come from this column. And then we need to make sure we do the one with the correct df, which is 50. So I need to keep going down because I'm not far enough to get that 50 yet. So now I am, and just highlight the df50 row, which is right here. And we can see that the t of 0.05 column intersects with the df of 50 row right here at 1.676. So that is going to be the t-score that we use in this process. So switching back over here, our t star is 1.676. So now we've assembled all the pieces we need. So let's jump into the formula. We have our x bar is 1907.42 plus or minus the t-score that we just found, 1.676, times the sample standard deviation, which was 204.57, divided by the square root of the sample size, which was 51. So we'll copy down our x bar, which is the point estimate, 1907.42, and then we need to add and subtract the margin of error. That margin of error comes from calculating this piece right here. So we'll fill that in right here. So let's switch over to the calculator and calculate the margin of error. All right, so we start off with that t star 1.676 times the sample standard deviation, which was 204.57, divided by the square root of our sample size, which was 51. We want to match the number of decimal places on this with our point estimate. Our point estimate was 1907.42, which had 2 decimals, so we want 2 decimals on this as well, which looks like 48.00, but those zeros are followed by a 9, so we have to round up, and that's going to be 48.01. So switching back over to here, that's going to be 48.01 for our plus or minus piece. And then if we do that plus or minus on the calculator, when we do the subtraction, so if we look at this as 1907.42 minus 48.01, with that subtraction piece, we will get 1859.41. And then we switch over, and now we do the addition piece. And when we do the addition, we get 1955.43. So they started off by asking us to find a confidence interval, and that's what we have in front of us now. But active learning doesn't really let us answer that complicated, so we've got some specialized instructions here for what they want us to enter. They said to only enter the margin of error E. So the margin error E was that part right there, the 48.01. So that's the piece that would go into active learning, is just the 48.01. So that's what I would enter in. Sometimes they ask you for the left boundary. If they do, you'd enter that number. Sometimes they ask for the right or upper boundary, and then you'd enter that number. But this time they wanted the margin of error. So that's this one, the 48.01, coming from the plus or minus piece right there. So that's what we want to enter into active learning. Again, things that can go wrong: forgetting to split the leftover 10% into 0.05 on each side. You can avoid that error by making sure you add all 3 of these numbers and make sure you get a total of 1. Make sure that if you have going a little crazy with color here. Let's do it here. If we have 2 decimals right there, then we need 2 decimals right here on our margin of error. Make sure that those decimals on the X bar match the decimals on the margin of error. All right, hopefully that helps you out. Good luck as you return to the quiz.